All right, so you have gravitational lensing, so uh therefore you have gravitational lensing. You see the moon, and you see the sun. If you were looking at the regular eclipse would the moon would be very small, and the sun would be a lot bigger around it. So the perception is that uh, in reflective in reflective lensing, you're literally seeing an image. You're looking you're looking into the telescope, and your vision of sight into the solar eclipse is at an angle. So that angle gives you the perception that you're actually seeing. And then the other side, they'll have another mirror, and you see off the other mirror, and that other side will allow you to see. It'll actually the mirrors in the reflective telescope in the 1920s were actually what they were actually doing is expanding their line of sight. Now, in my opinion, Einstein is just stating that you have uh, you have matter. So, I mean, in one degree of sight, you're looking at the reflexive lens, and the reflexive you have to look in at like a downward angle, and then it shoots. And then it shoots to your line of sight. Okay, so your line of sight down here, it bounces off a mirror, it reflects, and it is able to go outside. And you can add another mirror, and it'll go at another distance. They can add a mirror here, um, and add a mirror here to bounce off this site. And if you see it at an angle, seeing you're actually seeing what's farther away, closer up. Um, but in actuality, like it's just the mirrors. You'd actually be seeing further, but the mirrors are expanding your line of vision. So whatever is closer is able to expand. So in the Eddington experiment, the moon was able. The moon was looking bigger than it really was because obviously something like a reflective telescope with mirrors, which is what the Eddington experiment used, wouldn't work on the sun. It wouldn't work on the sun because the sun is so much further away relative to the moon. Since the moon is at a closer proximity, that um, it is able to perform uh, the reflective pattern. So again, in my opinion, what happened with the solar eclipse is that E equals mc squared. You have the sun, or sorry, you have the moon covering the sun's corona, and then you have so you see the moon, and then its rays are coming around the sun. So you can either barely or you cannot at all see the sun's corona, and that's in the reflective lensing. But if you were looking at it with uh, what's the other telescope? Like normal binoculars. If you were even binoculars would expand your line of sight. The only thing that really matters, I believe, in telescopes are their line of sights, not their magnification. If you don't have the right horizontal width to be able to um, give you that intense to be able to give you the ability to capture that intensity with the magnification, then it doesn't matter. So I'm just saying width is the only thing that matters with telescopes. Is your line of sight or the event horizon, like uh, so to speak, the horizon of what you are able to capture. So if you were looking at the normal solar eclipse, the sun, I mean, I'm not saying it would be massive behind the moon, but you would clearly be able to see the sun's corona would be almost two times the size of the actual moon in physical reality. Okay, and both of these experiments, what is happening are they are taking place in physical reality. And so, in this experiment, the moon looks huge, because you could say even that the sun is the control. In this experiment, the moon is huge. In this line of sight, in the reflective line of sight, the moon is huge. Okay, and in this in your normal vision, your normal line of sight, your normal horizon, the moon is twice as small. So that's what I'm saying. That's what I'm saying. So I'm saying that energy. So I'm saying that there is no way on this fucking planet that somebody as infamously smart as Albert Einstein ever said some jumbo or some mumbo jumbo shit like, oh well, the space is bent and all this shit. I mean, he's in what he is saying to me is that he has a line of sight in the reflective scope, and he is able to see these particles. He is able to look at these particles to be able to have an expansive view of these particles. So you have one particle here because it is an illusion. It's not a timeless illusion. It's not a singularity illusion. He's not contriving singularity. He's just saying, I'm looking at these particles. And they're able to get me to see these particles, or I should say, this graphic. He's like, but if I don't look, and he's like, the other constant is if I don't look at these mirrors, then I get a different graphic. And yeah, that's all it is, and that's all E equals mc squared. So normal line of sight, you get a smaller graphic, and reflective line of sight, you get a bigger graphic. So all he's saying is that light is reflective. He's saying E equals mass, mass times constant squared. He's just saying there's a reflexatory or reflective matter in the universe, and that has to be all misconstrued and misguided and turned into metaphysics. Okay, and my belief is that metaphysics is what people insist that physics is doing. But I would genuinely, well, I shouldn't speak too soon. Oh, fuck.
Is the one moving past outside the window. Therefore, you'll calculate that the cat has some kinetic energy, that is, energy of motion. And when you see the cat emit the flash of light, you'll again measure that its energy decreases by the energy of the light. Except, now that you're moving, special relativity tells us that time passes at different rates for you and the cat, so you'll measure a different value for the frequency, and thus energy, of the light. This is the relativistic Doppler effect, and for our purposes, it amounts to multiplying the energy of the light by 1 plus your velocity squared divided by twice the speed of light squared. So to recap, if you take off at velocity v, you'll see the cat gain some kinetic energy ke1, then at the flash, you'll see the cat's energy decrease by e times 1 plus v squared over 2c squared. On the other hand, if you wait, you'll see the cat's energy decrease by e, and now when you take off, you'll see it gain kinetic energy ke2. But this is silly. You never touch or otherwise influence the cat in either case, so we should get the same total energy at the end. Rearranging,
What did you just say about the rock?
When you take off, you'll see it gain kinetic energy ke2. 1 plus v squared over 2c squared. On the other hand, if you wait, you'll see the cat's energy decrease by e, and now when you take off, you'll see it gain kinetic energy ke2. But this is silly. You never touch or otherwise influence the cat in either case, so we should get the same total energy at the end. Rearranging, we see that the kinetic energies before and after the flash must be different. And the kinetic energy of an object is 1/2 of its mass times its velocity squared, but we know that the velocity was the same in both cases. So in order to account for the difference, the cat's mass must change when it emits the flash of light. Now, if we cancel things out, you can see that the change in mass of the cat must be equal to the energy of the light emitted divided by c squared. Or, as you've heard before, E equals mc squared. its velocity squared, but we know that the velocity was the same in both cases. So in order to account for the difference, the cat's mass must change when it emits the flash of light. Now, if we cancel things out, you can see that the change in mass of the cat must be equal to the energy of the light emitted divided by c squared. Or, as you've heard before, E equals mc squared.
Wait, what the fuck did this motherfucker just say?
For the difference, the cat's mass must change when it emits the flash of light. Now, if we cancel things out, you can see that the change in mass of the cat must be equal to the energy of the light emitted divided by c squared. Or, as you've heard before, E equals mc squared.
Alright, I'll try to, Alright, please don't play a fucking ad. Oh, fuck you, god damn it. Oh, fucking goddamn. Alright. Alright, so all I'm saying is that, alright, you have Newton's, you have Newton's, gravity, you have Newton's gravity equation, so you have two masses, divided by radius squared. Again, you have 2 points in time, you have a measurement of one object getting to another object, and you're dividing that equation, whatever the whatever those masses are, you divide that by the 2 points that they were in separation of, whatever's holding those points in gravity, that would be the radius, and you square that radius, and that's just your rope. That's your rope that is the gravity between two objects, two masses. That's Newton's gravity equation. So I'm just saying that's very rational. Nothing profound about that. But in terms of them playing this game with kinetic energy and saying, well, I would say that they're creating drag. Like if I'm running, and then I decide to run faster, the law of kinetic energy says that my gravity my gravity has to increase, and my what's happening? Like I have to, I'm increasing. If I'm running, I'm the smaller object than the Earth, so I'm running on Earth. So Earth has more kinetic energy, and I'm running. The Earth is going to give me more kinetic energy than I'm going to give the Earth. So it's like saying, since I'm running and moving at a speed, I'm just qualifying the gravity. Then it's like I'm floating or something. It's like that's the reason why we're floating in space. I mean, it doesn't make any fucking sense, but I'm just saying they're creating a drag. That's why many worlds you can just say, well, if it creates the drag, or I mean, you could say if force, if the force is equivalent to the Newton, and the Newton is equivalent to 1/10 of a kilogram, then another world, and to these guys, is really just 10 newtons is equal to my pet spider or something. And, I mean, I'm just saying that's how they're doing it, but obviously they're doing it with general relativity, but in this absurd way, and really they're causing, I mean, even to have the cat in that video just screaming Schrodinger. And what Einstein is saying is completely theoretical, in the sense that you're just using atoms, you're using the free space, you're using you should be able to say that every object in the universe has a temperature, um, even though everything has radioactive decay, so to speak. So, I mean, in a sense, there should be entropy, but at the same time, by no means should people be taking part in the singularity. But so yeah, I mean, I'm just saying what's wrong with E equals mc squared is that people are saying that there's a particle effect, and the particle effect is another theory. But I'm just saying Einstein's theory and the hypothesis or the experiment of his hypothesis is completely rational if you look at it in the sense that in the way that I believe Einstein would have. I mean, not to get too aggressively thinking that everybody in history was smarter than the people are now, and this happened 100 years ago, and now we have the Hubble telescope. And since Einstein looking at a solar eclipse, now we have people saying that they can see the end of the universe. I mean that, and nobody knows any of these fuckers. They just know, oh well, we live in a timeless universe, and these fuckers can see the end of the universe. I'm just saying, Einstein was probably right, and with all of this shit. um, so I don't know what to make of anything else. But I'm just saying there are theoretical ways to contrive this shit. But yeah, I mean, the problem is nothing changes. The size of the moon never changes. The size of the moon never changes. But when manipulate mass, as in you can when you manipulate mass, as in kinetic energy, that's when you can say that something looks different because of mass. Like there's you look at something and then you look at it again, but there was like a lens over your eye that made you see it differently, and that's all E equals mc squared ever fucking was. And so I'm just saying, to turn that into like ferrocells or gluons and this type of shit is fucking insane. But I mean, I guess that's kind of the direction they went in. I mean, if they groomed Einstein into, I mean, they didn't steal Einstein's fame like they stole Newton's. Even though Newton is the most famous physicist of all time, but they didn't Einstein. They groomed his fucking ass. So that's probably why he started talking all this shit. But I don't know if I have any other points. Again, I mean, I just feel like there will be ways into which these experiments will make sense. Like you could look. Well, I don't want to get into the double split, but I'm just saying. I mean, but then they spend they spend $20 billion on a physics experiment that fucking just does graphics that you could do CGI movies with. So that's fucking pathetic. But yeah, I don't know if I have anything else. I mean, like this or whatever. You could just say that. I mean, just to say that there's two photons here, and you're manipulating light with the impediments. It's the same thing as the solar eclipse, but you're manipulating the solar eclipse with a lens. In this case, you're manipulating the mass with with an impediment. So it's like they're changing mass with other masses, or they're calling light the mass, and they're changing the shape of the light and saying that's interdimensional. I mean, but that's shit. I mean, that's why I feel bad for these people. But I mean, there's ways to get this. Like you're one half one half of your mass. Okay, one half of your mass. uh, is equal. I mean, it's like saying one half of your mass is equal to half of your velocity of the speed of light. Okay, I mean that's what you could say kinetic energy is. One half of your light is equal to half of your full spectrum of light in the double slit, and that's like your drag or something. I mean, there's ways to look at this shit. I'm not saying I just don't think these. I mean, these fuckers need to explain themselves, they really need to explain themselves. But just the fact that people can make up any equations that they want and call it something and call it a physical phenomenon, they really can, because it's going to just be, yeah, it's going to be babble. It's going to be it's going to be like fucking babble, and you don't know what the fuck anybody's saying, but everybody's like telling the fucking truth or some fucking you know stupid religious shit like that. I mean, that's what it really is going to be. But you got Newton's gravity with the rope, and then you got Einstein's Einstein's real uh, thought form, constructed thought form on the actual Eddington experiment, or not this other shit that I would say metaphysics turned it into. So yeah, I think that's it.